Now this one is missing the property of exponents. I have to actually put this in. And the property that we're going to be looking at is this, that a to the m raised to the n power is a to the m multiplied times n. So that says that if I were to have y to the negative 3 raised to the third power, this is y to the negative 3 multiplied times 3, which is y to the negative 9, or 1 over y to the 9th. And they're going to make you write everything with positive exponents. When I'm looking at something like this, the first thing I do is there's the number. Number's not attached to the m. It's not attached to the n. The number is his own thing, and he's raised to the 1 power. If I were to write this out 5 times, I would be multiplying negative 2 times itself 5 times. So this would then become negative 2 to the 1 times 5, m to the negative 6 times 5, n to the 4 times 5, which is negative 2 to the 5th, m to the negative 30, n to the 20, 2 to the negative 2 to the 5th is negative 32. When we hit the chapter, I can't remember what chapter, I don't know what chapter it is in this book. I think it's chapter 7. You'll get pretty used to that. This one is 1 over m to the 30th. And this is n to the 20th. So what your book would do, 32 is over 1, n to the 20 is over 1. You'd have negative 32. N to the 20, and the denominator would be m to the 30. I hate m's and n's. I also hate u's and v's, so I'm indiscriminate with my hatred of certain letters. First thing I do is I go in and make sure everybody has an exponent. 6 has an exponent of 1, 7 has an exponent of 1, y has an exponent of 1. This is going to be 6 to the 3, x to the 6, 7 to the 3, y to the 3. So 3 times 1 is 3, 3 times 2 is 6, 3 times 1 is 3, 3 times 1 is 3. This is x to the 6th, y cubed. And now, if I want numbers, I'd have to take my handy-dandy calculator, which I won't do, and multiply them out. So we could say use calculator. To multiply out. Or you could do it by hand. I'm too lazy to do it by hand. Now again, 8 has an exponent of 1. 8 has an exponent of 1. So 1 times negative 2 is 8 to the negative 2. H, 3 times negative 2 is negative 6. R, negative 2 times 4 is negative 8. 3 times 1, it's 8 cubed. 3 times negative 3, r to the negative 9. 3 times negative 1, h to the negative 1. Oh, 3, thank you. See, you guys are alert. Woohoo! So now what do I have? I have an 8 to the negative 2 plus 3. If the bases are the same, you add the exponents. H to the negative 6 minus a minus 3. R to the minus 9 minus a minus 8. So that's 8 to the 1. Minus and a minus is a, oops, you should have told me, plus. So this is going to be an h to the negative 3. Minus and a minus is a plus. R to the negative 1. Who belongs downstairs? The h and an r. So it's going to be 8 over h cubed r. Or r cubed h. This one's a horror show, but I would simplify the inside first and then whap it by negative 3. Because what do I notice? I notice 3 divides 12 4 times, right? That would make life a lot easier. So I'm going to do the inside first. So this becomes 12. X to the negative 3, y to the negative 2, z to the 4th. 3x, y to the negative 2, z to the negative 4. 3 divides 12 4 times. So I'm going to have a 4. X to the negative 3 minus 1, because this is an x to the 1 power. Y to the minus 2 minus a minus 2. Z to the 4 minus a minus 4. 4x to the minus 4. Minus and a minus is a plus. What do you notice? The y's are gone. That's y is 0 power. Y to the 0. Z minus and a minus is a plus to the 8. So I have now a 4, x to the 4th, z to the 8th. And now I'm going to raise that to what power? Negative 3. So now I'm going to focus on the outside. 4 has an exponent of 1. 4 to the negative 3. X to the negative 12. Isn't that crappy? Z to the negative 24. So what do you notice? Uh-oh, what did I do wrong? Oh, this is x's minus. Thank you very much. Whew. Not as bad as I thought. So, In the numerator, you have an x to the 12. In the denominator, you have a 4 cubed and a z to the 24. You have an x to the 12, 4 cubed is 64, z to the 24. Yuck. That's the most complicated as it's going to get. That's good news.